Assalamu alaikum. Ali, can you hear me?
Walaikum salam, I can hear you.
Ali, what's an update? What are you doing right now? How much work? Just let me, actually, I forgot to start it, and we started from November 15, 234, right? Now, in this question, there is a pressure on the atmosphere due to atmosphere, and this pressure is keeping it in this position. And then we have a derivation. And the variation with height of the total pressure. Now, you will say that the pressure is not zero because there is some atmospheric pressure. Use data from figure 2.2 to calculate the density of the liquid in the cylinder. So the formula is P is equal to rho GH. If you rearrange it, this was the formula, and now we can take reading, or I think if we think about a concept of gradient, we can also go through this because the graph is P upon H. So what I was thinking, if I write this equation like this, I will be left with P upon H. And you can see from the graph, it is the gradient. Now, can you find the gradient of this graph? You can take 1.0 and 3 and y-axis. And denominator 1.5 minus 0. Now you can find the gradient from this.
I'm getting 1.33 into 10 power 5.
Now try this work.
I'm getting 1.36 into 10 power 4. 1.36 into 10 power 4.
Yes. A spring balance is used to weigh This is June 16, 234. A spring balance is used to weigh a cylinder that is immersed in oil, immersed in a liquid, cross-sectional area 13, cylinder, oil, thin wire, and the length of the length of the vertical side is 5 centimeter. Reading on the spring balance is 4.8. The length of the cylinder is 5 and the cross-sectional area is 13. Weight of the cylinder is 5.3. The cylinder is in equilibrium, but when it is immersed. This in terms of forces acting on the cylinder must be having one force downward, and there is a force tension should be, and plus there is a force which is U. What is U?
Upthrust.
Yes. So you will say that the tension and upthrust are balancing the weight. That is why resultant force is equal to 0. He says, fine, calculate the density of the oil. So first we should try to see what is the reading on the meter. The reading on the meter is 4.8. And the weight of the cylinder is 5.3. So you can say E plus U is equal to W. U is equal to W minus T. So you can find U.
Can't we use the density is equal mass over volume formula for this one?
No, but he's asking for density of the oil, not density of the cylinder. So that's why you have to use this formula. Upthrust formula, which is specially designed for the density of the liquid. So once you get the height for me, you can get this formula and you need to find density. The area is 13 centimeters square. Length is 5 centimeter.
I'm getting 783.6
For what density?
density.
Density is equal to, can you repeat the question?
783.6.
183.6. So we should round it.
780.
Acha, 783. Okay. State the two conditions for an object to be in equilibrium. The two conditions are resultant force is equal to 0. Resultant moment is equal to 0. Look, there are two conditions. Do you remember the wording for it? Algebraic sum of all the forces acting at one point is 0. Algebraic sum of all the moments acting on a single pivot is 0. Now, do you remember that?
Yes, I remember it.
Good. This is necessary to remember. And for every chapter, I have revision files and revision videos. So always better to improve any definition. And I have given a revision handout also. A uniform beam AC is attached to a vertical wall at end A. The beam is held horizontal by a rigid bar BQ. The beam is of length 0.4 meter and weight W. An empty bucket of weight 12 Newton is suspended by a little metal wire from NC. The bar exerts a force on the beam of 33 Newton at 52 degree. The beam is in equilibrium. Equilibrium means that both the conditions should be fulfilled. Calculate the vertical component of the force exerted by the bar on the beam. Now, if I go and I try to resolve this component, let's follow it here. So this angle will be 52. And you made a cut here. So it will be 33 cos 52. And it will be 33 sin 52. Now, what is the vertical? What would be the vertical component?
The sine 52.
Good. 33 by taking moments about A, calculate the weight of the beam. Now, he says moment about A. So it means he wants the pivot at A. So if I take pivot at A, 33 sin 52 will not be used. It is going through the pivot. And we have a force here. Now, this is an important thing to see that how we should consider the pivot at A. So I have to improve my diagram to manage the moment at A from A. So let's extend this force here. I have extended it here. to make the components shifting. Now, this is the case. Let's move this angle here. I'm just making the things more clear so I can show my components 52. This is 50, sorry. This is 33 cos 52 and this is 33 sin 52. I've resolved it. Now this is a good picture of what we are showing. We have a force here and we have a force here. Now I'm taking pivot at A. To avoid, to minimize the working, I'm removing the previous part working. Now, can you help me to make the equation W is in the center? It will be taking how much? What is the length of the rod? Length of the rod is 0.4. So this distance should be 0.2. Yeah, up to here. So let's start making the equation W into 0.2 and 12 into 0.4. Total clockwise is equal to total anti-clockwise. So make that equation wording. And now you see the 12 will go with 0.4. 12 will go with 0.4. And W will go with 0.2. Now, what about this 33 sin 52?
This will be anti-clockwise.
Hmm.
And 0.4 we will, 0.3 we will take.
Now, this is the equation. Now, this is the equation, and we need to solve it to find the value of W.
I'm getting 15 newtons.
You're getting 15 Newton. The metal of the wire in B has a Young modulus this. So this is Young modulus. Initially, the bucket is empty. When the bucket is filled with paint of weight 78, the strain of the wire increases by this strain. He says, what is the increase in stress? The formula is there. E is equal to so 2 into 10 power. So I need to find stress. See this working?
I'm getting 1.5 into 10 power 8.
1.5 into 10 power 8. He says its diameter. How to involve diameter? The second formula was FL upon AE. But that will take a long way. Just a minute. Why don't we apply stress formula? Just a minute. Stress is equal to force upon area. So I can find area from this equation. Under root we are taking because of the square, and this is the case. Now we are having this D. First you find area and then you find
I'm getting 4 into 10 power minus 4 as the radius. So we'll double this to find the diameter.
Achha, you are going for radius. Why you can go directly for diameter, as I said.
I used like area is equal to pi r square and then I did
Okay. Then what you are, if you double it?
I am getting 4 into 10 power minus 4 as the
If you
radius.
double it, it will be 8. If you double it, it will be 8 into 10 to the power minus 4, right?
Yes.
Now this is June 17. Two conditions. Now I take sigma F is equal to 0. Sigma M is equal to 0. A paraglider P of mass 95 kg is pulled by a wire attached to a boat as shown in the figure. You have a parachute and a paraglider is there. The wire makes an angle of 25 degree with the horizontal water surface. P moves in a straight line parallel to the surface of the water. The variation with time of the velocity of P is shown. Velocity and time. Initially, velocity is looking constant, and then velocity is increasing at a constant rate. Show that acceleration of P is 1.4 at time is equal to 5. So acceleration would be the gradient. He says at 1.4, I think we should take at 5. 5 is in here in between 4 and 6. We can take the gradient of this line, the whole line. For better accuracy, I'm taking the whole triangle. Now I can take, this is 4 and this should be 7.8. And how much this would be if it is 5, 4.2, 4, 6, 4.6. 4.6 and 10. So now I have marked all the values, so I can go for a gradient 10 minus 4.6. (7.8 minus 4). So let me know if you get an answer.
I'm getting 1.42.
1.42. Say we can take it 1.4 correct to 2 because he's asking to show it. Calculate the total distance moved by P from time t is equal to 0 to t is equal to 7.
In the above question, could we have like also done the same? Like we could have taken x as 5 and divided the velocity by it.
That would be risky because the line was not coming from 0. Directly reading from 5 would be a bit risk. Graded is the best option. Calculate the total distance moved by P from 0 till 7. From 0 till 7, do you think it will be a type of area because distance of from velocity time, how we get distance from velocity time?
Area under the graph.
Area under the graph. That's good. So we go for
For the constant one, we can just multiply it. Like
for the constant one, it's a rectangle now. So for that part, if you're asking, so you can do that. Initially, it is a straight line. And then it's going up. We need to find the area till 7. So I made a rough diagram here because that diagram is already used much. So if I take it 7, 0, and it's 4.6 and 10. 4.6. How much would be on 7? Can you locate 7 for me? This is 7. No, this is not 7. This should be 7.
.6. 8.8 I'm seeing at 7.
8.8. So it's 8.8 and 7 here. So now the picture is quite clear and we can mark it here and we have 7 and 8.8. And we have turning position is 4. Now we can put the area. You can take it as area of rectangle and area of trapezium.
When I don't remember the formula for trapezium. Whenever I try it in the exam, it becomes wrong.
No problem. You can further break it in a triangle and a rectangle. That is not a case because it's not important. Now for rectangle, it will be 4 into 4.6. I'm using trapezium as it's a case directly. It's a half into height. Height is 4 minus 7 minus 4, which is 3, into sum of parallel sides.
I don't understand this parallel sides, how to get them. The rest
Yeah,
I can.
you can break it in a triangle and rectangle, no problem. Break it in a triangle, make a triangle on the top. I will not do because it will mess the diagram. But the A2 can be further divided in a triangle and a rectangle, and do it, no problem. In a trapezium, there are two parallel sides, but this is not a good time to go for risk and try to understand how it works.
I'm getting 38.5 as the answer.
I've rounded to 39. Calculate the change in kinetic energy of P from 0 till 7. Formula. What is the mass of this object?
Can you give me like 1 minute? Just I'm coming.
No problem. Mass is 95.
For the answer for the above part, I was getting like 38.5.
Okay, I got it. That's good. And then it is 39. I rounded it. The next case, he says, calculate the change in kinetic energy. So I have made the data, and now we need to find change in kinetic energy.
I'm getting 2.67 into 10 power 3.
2.67 10 power 3. Say, perfect. The tension in the wire at time t is equal to 5 is 280. Calculate the horizontal motion, the vertical lift, and the he's asking vertical lift supporting T. He says the tension is there. So I make a I make an axis here to settle the components. He says that the tension in the wire at T is equal to 5 is 280. Tension is given 280 Newton. Calculate for the horizontal motion the vertical lift force supporting P. So it's 280, and if I take it here, if I resolve it, I will get T sine 25, and here I will get T cos. What should I take for vertical component?
The T sine 25.
T sine 25, and T is given 280. Then you get the T sine component.
T sine 25 is 0.43.
No, but the complete into 280.
The final answer I'm getting as 277.4.
280 into sine 25. How it can be more than this number? Sine always reduces the number, na? What is 280 into sine 25? It should go down 280, na?
It's 118.3. The final I'm getting as 277.3 answer.
How you're getting final 118, 90? This is the vertical component of tension. Now, if we come here, this is the weight of the boat, and this will be the weight of the person. Now, as we discussed in our previous example, there will be a reaction force. Should I take the weight of the boat or should I take the weight of the person? Has he given? I think he has given the paraglider of mass this. So the weight of the paraglider is 95 G. So that would be the value for R also. R will be equal to W. So there is another upward force. R is equal to W is equal to mg. And it is 95 kg. Total lift will be equal to 118 plus R. So you get this answer for me.
R will be equal to the mg. So we'll get 1049.
1049. 49. So it will be 1050. No, I think I wrote wrong. You said 1049, right? Or 1149.
1049.
I'm sorry. I wrote it how? The force are due to air resistance acting on P in the horizontal direction. So first we should see what is the horizontal tension. Horizontal tension is 2 cos 25. You can see the direction of motion, and there will be a drag force on this whole apparatus. So first we find T horizontal, that will be 280 cos 25. First find this is the horizontal tension.
It is coming as 253.8.
Resultant force is always equal to MA. We got acceleration. How much was our acceleration? 1.4. So if we model this apparatus as this, it's going in this direction. This is the reaction force. This is T horizontal plus backward resistance. This is the result. Resultant force is always equal to greater force minus smaller force. Let it say X. What is this 95 into 1.4?
It is 133.
We can solve to get X.
That is 368, 386.8.
3.
386.8.
Okay. So we got this force. We keep it up to here. And how it's getting above 253, X will go there and 133 will come here. It will be subtracted. Can you check your calculation again? Because X will go on the other side and X will be in X will become plus.
So 133 minus there.
So for yes.
Wrong answer. It's 120.8 now.
So we keep it up to here and we will do it in our next class. This is over for today. Allah Hafiz.
Allah Hafiz.
This is the first question for, this was the first question for today, and due to a recording error, I couldn't explain this part. This is the force acting on a block. He says calculate the vertical force that the surface applies to the block, normal reaction force. It is an equilibrium. So I have drawn a diagram, resolved it, and then I have used up is equal to down. Then examiner says find the work done by the force F force P. Work is equal to force into displacement. I took F sine theta because it is in the direction of the displacement. Then why the block continues to move at constant velocity means that the forward force is equal to backward force. The acting while the block remains in equilibrium, resultant force is zero. The figure shows a liquid in a cylindrical container. And he says derive, this is a fixed memory derivation for P is equal to rho gh. This is a memory derivation. And then this is the sketch when the maximum height, when the height is zero, pressure is not zero because it is there is an atmospheric pressure on it. Later it was in our recording, but the first question was not well discussed. Thank you.